We now find two numbers whose difference is 100 and their product is minimum. Let's say that one of the number is x and the other number is y. So it is given that the difference is 100. So we can write down x minus y equals 100. In fact, we can write down this as y minus x, and this equals 100. We can take any one of the number as the first number and the other as the second number, so it doesn't matter. So let's use this expression, that is x minus y equals 100, and we have to determine the product is minimum. So we say that the product, that is p, equals xy, and we have to determine that this product is minimum. First, I'm going to write down this p in terms of x by replacing y in terms of x. So this implies we can determine y from this equation. We get y equals x minus of 100. We first add y to both sides and then subtract 100. And when we do that, we get this equation, that is y equals x minus 100. I'm going to replace this y into this equation. So therefore, this becomes x times of x minus 100. We then distribute this, so it becomes p equals x times x is x squared, x times 100 is 100x, so it basically becomes x squared minus 100x. We can write down this p as a function of x because we have written the right side as everything in terms of x. So we see that this is a product function, and our objective is to minimize this product function. So for that, we are going to use the first as well as the second derivative test. So in first derivative test, we have to determine the critical numbers of this product function. For that, I have to find the derivative of the p of x function. So let me find the derivative of the p of x function, which is p prime of x. And this equals the derivative of x squared is 2x, and the derivative of 100x is 100. Now we have to set this equal to 0 to find the critical number. That is, the first derivative equals 0 to find a critical number. And this means if I replace p prime of x equal to 0, I get 0 equals 2x minus 100. We then solve for x from this equation. So from this, we get x equals 100 divided by 2, and this equals 50. So this is basically the critical number or the critical value of the product function. Now, to test that this critical number or the critical value gives the maximum or minimum value, we have to do the second derivative. We have to find the second derivative. So let me find the second derivative of p of x. So that equals, that is p double prime of x. And this equals the derivative of 2x is 2. And then derivative of 100, which is a constant, is 0. So we get p double prime of x equals 2, and this is always going to be 0. I'm sorry, always going to be greater than 0. And even if you plug in this the critical value into the second derivative, it doesn't matter because it is not a function of x. So since this is always greater than 0, we see that according to the second derivative, it is a point of minimum. So at this point, that is at x equal to 50, the product function p of x is minimum. So this confirms that we can consider one of the number as x equal to 50 because the product is minimum at this value of x. So we determine the one of the number x equal to 50, and this means we can determine the second number, which is given by y equals x minus 100. So let's find the second number, y equals x minus 100, and this equals 50 minus 100, and this equals negative 50. So we determine the second number, y equals negative 50. Therefore, we see that the two numbers are x and y. The two numbers are x and y. X is 50 and y is negative 50. So these are the two numbers whose difference is 100 and their product is minimum.